Hi, we're going to do a limiting reagent problem now. So if you look at the problem on the screen, we can recognize that this is a limiting reagent problem because it's giving information about two of the reactants. Not only this, but in this particular example, it's actually asking us about the limiting reagent. It mentions it specifically. The first thing I'm going to do is to rewrite the equation that I'm given and organize all the information and figure out what I'm being asked to calculate. So I have K2 PT Cl4 plus 2 NH3. Looks like I have a balanced equation because I have a coefficient here. Produces PT NH3 2 Cl2 plus 2 KCl. And if I take a moment to check this equation, I see that in fact it is balanced. I have 2 potassium and 2 potassium. I have a single platinum on the left and a single platinum on the right. I have 4 chlorine on the left. On the right I have 2 here, and another 2 in 2KCl is 4 chlorine. I have 2 NH3s, and because they stay as a group, I see in this formula I have 2 NH3s. So I'm going to write the information that I'm given in under each substance here. And then I'm asked for the limiting reagent, how many grams of the excess reagent are consumed, and how many grams of cisplatin are formed. Well, I'm actually going to look at the last thing first, and in order to figure out how many grams of cisplatin, on the way to figuring that out, I will answer question A about the limiting reagent, and then we will come back and we'll figure out B afterward. So the first thing is to organize ourselves. So I'm going to do a stoichiometry problem twice when I do a limiting reagent problem. I'm going to start out from each starting material. So for each substance, I want to figure out a number of moles. And then for each number of moles, for each reactant, I'm going to figure out how many moles and what mass of product I could make. Whichever one gives me the lower prediction is the one I run out of first and the one that I use for all further calculations. It's the limiting reagent. So I'm going to work out number of moles of K2 PT Cl4 and the number of moles of NH3. Each one is a mass over molar mass. And each one is 10.0 grams. Now if I go back to the question, I see that molar masses are given. That's very common in a stoichiometry problem. They're long and there's lots of work to do. So we don't want to torture you altogether. We give you the molar masses. They may not even be as precise as the one you could work out from the periodic table, but if we're giving it to you and telling you to use it, use it. It'll make your life easier. So the molar mass of the K2 PTCl4 is 415.08 grams per mole. The molar mass of NH3 is 18.04 grams per mole. and the molar mass of our product is 300.05 grams per mole. So if I fill these in, 415.08 grams per mole here, 18.04 grams per mole here, then we get out our TI, 10 divided by 415.08, so 0.0241 to 3 significant figures. Now, I could do this calculation as well, but because I have this number on my calculator unrounded, I'm going to finish the calculation for this one first and then come back to do this one. The second step is to figure out the number of moles of product from the number of moles of the first reactant. Number of moles of PT, NH3 bracket 2 Cl2 is the number of moles of the first reactant, K2, PT, Cl4 times our mole ratio, and the mole ratio is the coefficient of the required substance over the coefficient of the given substance. Where there is no coefficient, we know that this is a 1. So required is a 1 and given is a 1. So my number of moles of my product is going to be the same as the first reactant, 0.0241 mole. Now we're into the third step for this first reactant to figure out the mass of PT NH3 2Cl2 is its number of moles times molar mass. So 0.0241 mole times the molar mass of the product, 300.05 grams per mole. So when we key that in, I got 7.23 to 3 significant figures. So I had left this number on the calculator screen as I went into this calculation and simply multiplied by that molar mass. So there's my unrounded answer. That's one possibility. If I work it from the other reactant number 2, I have 10 grams as well, but divided by its molar mass, so I have 0.554 moles of reactant 1. The number of moles of PT NH3 2Cl2 that I could make from that is the number of moles of the second reactant times the mole ratio, and again, it is required over given, the one I want to know about divided by the one that I have information about. So 1 over 2. Very important that you get the order correct there. 0.554 moles times 1 over 2. So if we take that last answer and basically divide by 2, we're going to get 0.277 moles. Now, the mass of PT NH3 2Cl2, our product that we could make from that, would be that number of moles times the molar mass of the product, 0.277 moles times the molar mass of the product, 300.05 grams per mole, times 300.05, and we get 83.2 to 3 significant figures. So we see that that's a lot more. So what I'm going to do here is I'm not going to make a mess, but I'm going to draw one line through this. This is my limiting reagent. We only have enough of the first reactant, K2PtCl4, to make 7.23 grams of product. This is the one we run out of first and the one that limits the reaction. We have enough of the second reactant to make 83.2 grams, but of course we don't have enough of the first reactant to do that. So this is in excess. So the answer to question C is 7.23 grams. The answer to A is that the K2 PtCl4 is the limiting reagent. So we're going to state all these at the end. We also need to figure out B, how many grams of the excess reagent are consumed. So we go back to the moles of the limiting reagent. This is important, and this is what's used for all further calculations. So in order to get B here, we can say the number of moles of NH3 reacting is the number of moles of the limiting reagent K2 PtCl4 times our mole ratio. I want to find out about ammonia, so ammonia has a coefficient of 2, and the K2 PtCl4 has a coefficient of 1, so required over given 2 over 1. So 0.0241 moles times 2, and rather than assume anything, I'm going to go back to the unrounded value. So I'm going to get that on my calculator screen again. 10 divided by 415.08. So there's my original value. I'm going to multiply it by 2, and I get 0.0482 to 3 significant figures, but I'm going to leave the unrounded value on the screen. 0.0482 moles of ammonia. That's how much can react. And the mass of NH3 reacting is the number of moles times the molar mass. So 0.0482 moles times the molar mass for NH3, which we've said was 18.04. So take my unrounded value on the screen times 18.04, and to 3 sig figs we have 0.869 grams. So just to answer the questions, A, K2, PTCl4 is the limiting reagent. In part B, 0.869 grams of NH3 are consumed. And C, 7.23 grams of cisplatin formed. And there you have it.